Alright guys, let's take a look at how to graph an exponential function given the equation and how to identify some of those key features. They're really important things you need to know about that graph. Okay, so looking at the equation here, the 16 is our y-intercept, okay, and the 0.5 is our rate at which we are growing or decaying. So when it asks for your starting point or y-intercept, it's talking about the 16. And we can include that while we're making our table. Anytime you see 0, that's telling you where the y-intercept should go. So 0, 16 is our y-intercept. Now our rate is 0.5. Something to remember about rate, if our b value, the rate, is between 0 and 1, that means it's going to be a decay. That means it's something like 0.5 or maybe 1/3 or 1/4 if it's a fraction. Okay? Then if b value is bigger than 1, like 2 or 3 or 4, that would be a growth. So in this case, 0.5 is less than 1, therefore we know it's going to be decaying. Our numbers are going to be getting smaller. So we're going to take that 16 and multiply it by 0.5. 16 times 0.5 is 8. 8 times 0.5 is 4. 4 times 0.5 is 2. 2 times 0.5 is 1. So you can see that we have many points. Basically what's happening is it's taking half. So let's go ahead and graph it. We'll plot our y-intercept, 0, 16. The next point is 1, 8. The next point is 2, 4. And then 3, 2. And then 4, 1. And when we graph it, I'm going to graph it from the top with an arrow going up, because it does go up forever. I'm going to connect all these points, and then it's going to curve going to the right. And it's going to go in that direction forever as well. Now let's talk a little bit about some of those key features. So we know that there is a y-intercept at 16. There is no x-intercept. The reason why is because we have this thing, this line right here, that is called an asymptote. Okay? Asymptote. Okay? This line is a boundary line. That graph, this little arrow over here, is going to keep going to the right, but it's never ever going to cross the x-axis, that asymptote, that dotted line. So we know our graph is never going to go any further than that line. And the equation of that asymptote is y equals 0. And that never changes. Okay, it's going to stay y equals 0. Now our domain, if you recall, domain are the x values and range are the y values. So when we're finding the domain, we're thinking from left to right, just like the x-axis. So if I'm looking to the left, you can see that this arrow goes to the left forever, and the arrow over here goes to the right forever. So our domain would be all real numbers. And that's exactly the terminology that they'll use on the STAR test. Now for range, we're looking for the y's, which means up and down. So we can see it's going up forever up here, but it's not going down forever because of that asymptote, the boundary line. It's never going to cross that boundary line. So it can't go below 0. It includes all the y values up here, but it will never go below 0. So all our y values have to be above 0. Another word for above is greater than. So all our y values have to be greater than 0. And of course we already mentioned that since our rate is 0.5, that's less than 1, this is a decay. So there's a few things about key features. I hope this was helpful, and good luck on your test next week.